Okay, so in this video we're going to quickly clear up why simple covalent molecules have very low melting and boiling points. Because we're told that a covalent bond is extremely strong. So if a covalent bond is extremely strong, why should the melting and boiling points be so low? Now, a good example for this is nitrogen. So if we have nitrogen, we know that a nitrogen atom is in group 5 of the periodic table. We don't need to know that, but you could easily look it up in the periodic table. I'm going to tell you though, it is in group 5, which means its outer electron shell, or the outer energy level, has 5 electrons in it. Now, let's just draw those in. So 1, 2, 3, 4, 5, like so. Now, if we have another one of those, like so, we know that this also has 5 electrons in the outer shell, and the outer energy level is happy if it has 8. So each one of these nitrogens wants to gain an extra 3 electrons. So how's it going to do that? Well, it's not a metal, and it's not going to lose any electrons, and it's not going to gain any electrons, because metals and non-metals bond together via ionic bonding, but these two nitrogen atoms are the same thing. They're both non-metals. And so what we're going to form here is, of course, a covalent molecule. Now, if we had nitrogen, let's have a look at a bigger diagram actually. So if we have nitrogen forming a covalent bond, and I'm going to do the dot and cross diagram so you can see where the electrons are coming from. So let's say that we overlapped and we shared 1 electron each. We'd have 1, 2, 3, 4, 5, and that'd be shared with 1, 2, 3, 4, 5. Now let's take a look. Each nitrogen now has 1, 2, 3, 4, 5, 6 electrons in the outer shell. That's not enough because we need 8. So this really can't work. And so what if we extended this into a double bond? Like so. You see, we've now moved one of the electrons from each nitrogen and shared them. So now we have 1, 2, 3, 4, 5, 6, 7 electrons on the outer shell. So this is looking better, but it's still not enough. So now we're going to need to share 1 more electron pair. And so that will look something like this. Okay, so we've now moved 1 more electron from each nitrogen atom, and now we have 3 electrons being shared. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 7, 8 on both nitrogens, and they're both happy. Because we've shared 3 electrons, this is called a triple bond. And we can also draw that like this. Remember, the sticks can represent a covalent bond, like that. Now, you would think that a triple bond is extremely hard to break, and you'd be absolutely right. So why does nitrogen form a gas at extremely low temperatures? Why is it not a solid or a liquid? Why is it so easily broken down? Well, that is because in order to boil and melt a simple covalent molecule, we are not trying to break these bonds. If we had a room or any container full of these, so like this, the only thing which is holding these guys together is forces between the molecules, so like this. And you might be thinking, well, what are those forces? Because these molecules aren't charged. No, they're not charged. These are known as intermolecular. Inter just means between, and molecular, so between molecules. These are very, very weak. They are very weak in comparison to an ionic bond and a covalent bond. And because they're so weak, we can break them down very easily at very low temperatures. And that's exactly what happens in nitrogen as it forms a liquid and then a gas. So liquid nitrogen is still a liquid at around negative 196 degrees Celsius, and so that's extremely low. So forming nitrogen gas is very simple. So these bonds need to be broken down, or these forces need to be broken down, and these are very weak forces of attraction. So weak, they're forces of attraction. And this does quite nicely explain why things like diamond have such huge boiling and melting points, and that's because there aren't intermolecular forces, because there are no molecules. Every force, imagine all of these molecules being held together by covalent bonds. That would be extremely strong. So the only way that you break that down is by actually cracking open the covalent bond, which requires a lot of energy. With nitrogen gas, we don't need to break down the covalent bonds. All we need to do is break down the intermolecular forces, and that is actually very easy. And so that really does explain why simple molecules a lot of the time are gases, and some of them, like water, will be liquids, because the intermolecular forces are way weaker than a covalent or an ionic or even a metallic bond. Okay, so I hope that's cleared that up. Just wanted to briefly go over that because it is something that people get confused with. If you do have any questions on it, please do contact me using the form below and I'll be happy to answer, or leave a comment in the YouTube comment box. So thanks for watching, and I'll see you in the next video.